As you may have guessed, this is a very complex and difficult question since we are trying to solve a system of equations where there's 3 equations and 3 variables. So let's dive right into it. The strategy I'm going to use here is called elimination. And the idea is that we're going to multiply one equation by a term so that one of the variables have the same coefficient or the opposite, like 2 and negative 2, so that if you add or subtract the 2 equations, one of the variables will cancel out. For example, if I were to double this equation, then 2x would become 4x, and then if we take that and add this equation, well, then those x terms would cancel out. 4x plus negative 4x would become 0. So let's go ahead and do that. So this top equation will become 4x plus 6y minus 8z equals negative 2. And then we're going to add the other equation, which is negative 4x plus y plus z equals 16. And this will give us a new equation of 7y minus 7z equals 14. Now let's try doing that elimination method in a different way. So let's try and see what happens if we take the first equation and subtract 2 of the second equation, because then, again, we would be eliminating those x's. So let's go ahead and write this out. We would have 2x plus 3y minus 4z equals negative 1. And then we're going to subtract double of that middle equation. So 2x minus 4y plus 5z equals 6. Okay, so if we subtract these, the x's will cancel out, and we'll get, let's see, 3y minus negative 4y is positive 7y, and then negative 4z minus 5z. Oh, my apologies, I forgot to double that z term. So it used to be 5z, it should be 10. Okay, so negative 4z minus 10z is negative 14z. And that's going to equal negative 1 minus 6, which is negative 7. Okay, so interesting now is if we take a look at what I've written in red here, we have 2 new equations with 2 variables. 7y minus 14z equals negative 7, and 7y minus 7z equals 14. So now we can actually use substitution again here conveniently, quite easily, because both of them feature 7y. So what we can do is subtract them from each other, and then all we'll be left with is an equation where z is the only variable. So let's go ahead and do that. So we're going to, let's take the one on the right here and subtract the other equation, which is 7y minus 14z equals negative 7. Subtracting those will give us a new equation where the 7y's will be canceled out. Negative 7z minus negative 14z is positive 7z, and that's going to equal 14 minus negative 7, which is 21. Oh, well, that's easy. That just means z is equal to 3. 21 divided by 7. Great. We're one step done. Now that we know z is equal to 3, we can go back to this earlier equation, replace z with 3, and solve for y. So let's go ahead and try that out. So let's just bring that over here. So 7y minus 7z, now we know z has a value of 3, is going to equal to 14. So let's go ahead and solve this guy. So 7y minus 21 equals 14. If we add 21 to both sides of the equation, we'll get 7y is equal to 35. And then all we need to do there is basically divide by 7. 35 divided by 7 is 5. Awesome. Now we know we have our y value. Now to figure out our x value, we can pick any one of those three equations, replace y with 5, z with 3, and solve for x. Let's go ahead and get started. I'm going to pick this middle term just because x doesn't have a coefficient in front of it, so it should be easier to solve. All right, x minus 2 times y being 5, plus 5 times our z value of 3 equals 3. So this becomes x minus 10 plus 15 equals 3, which is x plus 5 equals 3, which means x equals negative 2, and that's 3 minus 5. So there you have it. We've now solved our system of equations. We've got x equals negative 2, y equals 5, and z equals 3. All right, that would be it for this video. Thanks for visiting JD's Preparation.